I'd like to mention that there will be breaks, there will be a luncheon, and there will be something known as a poster tour, which some of you may be familiar with, namely that the people who present posters will not just stand there. They will be giving 2 to 3 minutes each of a tiny little talk, but that will really be a good elevator pitch and will be a fantastic opportunity to learn to present, because we will break up into 4 teams and you will have a whole audience that will come to look at your poster. So please enjoy and maybe prepare mentally. In addition to the data blitz that you see there, we will ask the 3 awardees of the, I don't know if it's the best poster, but a really, really great poster, who will get monitor rewards, to come up to the podium here, and my co-MC, Professor Yasa, and I will provide the awards. I think these are all the points I'd like to make, with one major exception, and that is to thank James Weinstock, the Director of Operations, who's really been working with a small army of amazing people from all over to make this possible. James, are you here? All right, stand up. Yeah. And if I have to start thanking all the people who helped James, we'll take the whole day, so I'm going to stop right here. So with this in mind, let's just go ahead and go directly into the first talk, and it is my absolute pleasure to introduce our first keynote speaker, Dr. Christina Chambers. Now, you know me, I don't often read things, but this is such an amazing CV that I have to read it, so forgive me. So Dr. Christina Chambers is a professor in the Department of Pediatrics, School of Medicine at UC San Diego. She is, 1, Chief of the Division of Environmental Science and Health, co-director of the Center for Better Beginnings. She's a PI of the MotherToBaby Pregnancy Studies and the UC San Diego Human Milk Research Biorepository. And both of these nationwide longitudinal cohort studies focused on the safety of medication, vaccines, substances, infection agents, and other environmental exposures in pregnancy. Dr. Chambers co-directs the Healthy Brain and Child Development, i.e. the HBCD study that our county center just became part of. They're incorporating the Quick 5 questionnaire in the core tests that they're doing. Dr. Chambers also leads research and educational initiative in the US and internationally on the prevention and treatment of children with fetal alcohol syndrome. She co-directs the Center for Population Science and Community Engagement in the Clinical and Translational Research Institute at UC San Diego, which supports clinical research and development. She has got close to 300 papers and the most amazing, impressive list of grants and contracts that I've ever seen. In addition to the large consortia that I just told you and her own research program on these, as well as fetal alcohol syndrome, Dr. Chambers has been able to shepherd and coerce and induce pharma to test in pregnant women the safety of any medication that they would like to give to individuals. And I think the leadership and pioneering role in testing these in pregnant women and really understanding if there's a specific susceptibility is really a crucial part of women's health that we need to pay attention to. So I'll stop here and let's give a big shout out to Professor Chambers.
Thank you so much, Dr. Barham, for that lovely introduction and for me to learn more about the Conte Center. This is an incredibly impressive center, all that you've done and all that you will be doing. I'll just give a brief sort of caveat about the introduction. I'm going to be talking about the Healthy Brain and Child Development Study, and I'm really not going to be able to present any data from the study because the study is just being launched, but I know a lot of you, just looking at your faces, are trainees, and I think this is the importance of this talk is really to give you sort of a taste, hopefully to get you excited about opportunities to be able to use these data as they start to be released at the end of this year to test multiple hypotheses that you might be thinking of now or you haven't thought of yet. I also want to give you the pre-admonition that I'm an epidemiologist, and as Dr. Barham says, I study prenatal exposures and lactation exposures in terms of safety or risk for short and long-term child development, including risk for birth defects, neurodevelopmental disorders, and so on. But I'm not a neuroimager, I'm not a psychologist, I'm not an EEG specialist. So some of the things that you may have specific questions about, I can give you some kind of general answers, but might point you to the person who has that expertise or leads that expertise in the HBCD study. So with that disclaimer, I put some of our funding sources. And I'm going to start by just giving you the quick 20,000-foot view of what HBCD is. So this is a longitudinal observational study that aims to understand normative neurodevelopment from birth to 9 to 10 years of age, with an emphasis on providing information on the impact of in utero exposures to potentially harmful substances and environments. So really a twofold or two-pronged set of objectives. And I want to sort of step back and say that HBCD, we really like to think of this as sort of the prequel, if you will, to the ABCD, or Adolescent Brain and Cognitive Development Study, which I think many of you are familiar with and has been highly successful in terms of setting up a nationwide longitudinal cohort study that has served many purposes and been very lucrative, if you will, or productive in terms of publication and supporting grants. So the Adolescent Brain and Cognitive Development Study is a longitudinal study of about 10,000 children, it's actually more than that, from ages 9 to 10, so that's when they were recruited at that age, and then followed, and are continuing to be followed through early adulthood to assess factors that influence individual brain development trajectories and functional outcomes. And so just briefly, the research objectives of ABCD are to describe individual developmental trajectories, so brain, cognition, emotional, academic, and factors that can affect those trajectories, to take advantage of the opportunity of having this nationwide cohort followed longitudinally to develop national standards using, close to state-of-the-art technology of healthy brain development, to investigate the roles and interaction of genes in the environment on development, to study how physical activity, sleep, screen time, sports injuries, and other experiences affect brain development, to look at factors that influence the onset, course, and severity of mental illnesses, and to understand the relationship between mental health and substance use, and to study how use of different substances, including caffeine, nicotine, alcohol, marijuana, affect developmental outcomes and vice versa. So this is not very updated, but gives you an idea from grants that have been funded for investigators that have leveraged ABCD data. So using ABCD data for secondary data analysis, using this open science data model that ABCD was initiated with from the start, releasing data for the public to apply to use on an annual basis. I believe they're in their 6th release now. And so this is going back to 2020 and 2021. You can see that more than 50 funded grants leveraged ABCD data and continues to go along at that pace. Importantly, and here's an example of a publication that came out of ABCD out of Mass General Hospital by Brofman, published in PLOS One, looking at the association of adverse prenatal exposures and their burden with respect to child psychopathology in the Adolescent Brain and Cognitive Development, or ABCD study. So in this paper, they laid out that common adverse prenatal exposures associate with steep increases in risk for psychopathology at ages 9 through 10. And they note note, and ABCD acknowledged that, importantly, the information that's collected on prenatal exposures and everything that happened up to prenatal life to 9 to 10 years of age is collected retrospectively, and the prenatal exposure data is collected at least 10 years after the fact. So important to be able to kind of fill that gap with data collected a little bit closer to the time those exposures took place, with maybe more precision and detail that would allow us to turn around and replicate these findings or not. So that's one of the reasons for kind of defining HBCD as the prequel to HBCD, or to HBCD to ABCD, and some tremendous advantages in having the two studies coordinated in a synergistic fashion. So an overview of the study is that this is a prospective longitudinal study of child development from pregnancy through the first 10 years of life at least. And the target sample size at present is 7,200 mother-child pairs recruited in mid-pregnancy over a 3-year period of time. So each one of the 26 sites starts with a target sample size of about 300 with a little extra accounting for attrition. And those 26 recruitment sites across the U.S. Were selected for a variety of reasons, having the capacity and the capability to conduct this complex study, having the technology and infrastructural resources to be able to carry out the study measures, but also importantly representing the diversity as a whole of the population of pregnant persons across the U.S. So assuming that each site is recruiting in their catchment area a sample that is generally representative of pregnant persons delivering babies in their area, that taken as a whole, the entire consortium sample is intended to represent the U.S. population. And then, as I mentioned, the study is also intended to be aligned with and benefit from synergies with the predecessor and ongoing ABCD study. And there is quite a bit of overlap in terms of study sites and study investigators and tools and processes, and we've definitely benefited from lessons learned from ABCD. So there are two main questions, and I'll follow this with the detailed study objectives, but generally we aim to answer two main questions. What are the developmental effects of prenatal opioid exposure? And I'll say a few more words of why the emphasis on opioids, and other substances on children from birth through middle childhood. And then secondly, and equally important, what are typical or normative developmental trajectories for children from birth through middle childhood in the context of variable environments? So these are the detailed study objectives for HBCD. What are the typical neurodevelopmental trajectories, and what is the normal range of variability in brain development from birth through childhood? How do biological and other environmental exposures affect these developmental trajectories? How do genetic influences interact with environmental factors to influence neurodevelopment, cognitive, emotional, and social behavior? How does early life exposure to opioids, other substances, and/or other adverse environmental circumstances affect these developmental trajectories? And are there key windows during which the impact of adverse exposure, such as stress, influence later neurodevelopmental outcomes differentially than other windows? And are there key windows during which ameliorating influences, such as substance use disorder treatment for the parent or social economic support, are protective against potential neurodevelopmental insults of early adverse exposures? And then what is the impact of early parent caretaker interactions with their children on later health and other outcomes? So a word about opioids, a focus on opioids from the outset was important for this study for the obvious reason that this is just a critical public health issue in the United States and elsewhere. So using opioids as an example, between 2004 and 14, the number of infants born with neonatal opioid withdrawal syndrome, or NOWS, increased 433% from 1.5 to 8 per thousand hospital births. In 2017, 7.3% of pregnant women reported using an illicit drug, and polysubstance use is pretty much the norm. Early exposure to substances, including pre or perinatally, has been linked to greater risk for the child developing substance use disorders themselves. And prenatal exposure is also associated with other behavioral or mental health problems, including ADHD, conduct disorder, and anxiety. But to date, it's been difficult to establish causal links due to the myriad of confounding factors, such as socioeconomic, environmental, and genetic influences that may play a role in addition to the biologic plausibility that the exposure itself is impacting these outcomes. So the domains of assessment, and I'll say a few words at the end of this talk about the first 3 study visits and what the measures are in those visits. But in general, the domains of assessment included in HBCD are shown in this slide. So we include EEG for baseline, auditory evoked potential, visual evoked potentials, and face object ERP tasks. The study, of course, relies heavily on MRI for structural diffusion, resting state, connectivity, and MR spectroscopy. We're capturing biospecimens from the mother in the prenatal visit and from the child at subsequent visits for substance use in the mom, genomic, epigenomic, nutrition, toxins, and then at the time the study was proposed, COVID-19, which continues to be relevant. And then interview or questionnaire data about substance and other risk and protective factor exposures, questionnaires and individual face-to-face testing for behavioral, observational, and neurocognitive outcomes or assessments. And then we have included 2 wearable biosensors for capturing heart rate variability, sleep-wake cycles, and physical activity in infants. Funding for the study is led by the NIH Drug Abuse Institute, NIDA, as the lead NIH institute, but there are several other institutes who are contributing funding and resources and guidance, including NIMH, NICHD, NIAAA, OBSSR, Office of Research in Women's Health, the Office of Minority Health, National Institute of Environmental Health and Sciences, Neurologic Diseases and Stroke, and engineering and devices. And we've also received some funding and support from the Eye Institute to introduce vision screening at very young ages. A initial substantial portion of the support for the study came from the NIH HEAL initiative. So thus the title of the study has HEAL capitalized as HEAL as part of Healthy, with the HEAL initiative having a focus on improving treatments for opioid misuse and addiction, with a subset of studies being funded that are looking at preventing newborn outcomes. This collaboration of the consortium with the NIH is led by a scientific director at NIDA. The HBCD acting scientific director right now is Kathy Cole, who has been in that role for the past several months. And then our program officer from NIDA is Janani Prabhakar. And then our administrative core has liaison science officers from other institutes, Julia Zare from NIMH and Erica Spots from OBSSR. And our data coordinating center has liaisons with science officers from NIAAA, Ben Ju, and from Neurologic Diseases and Stroke, Rebecca Homer. This is just a snapshot of the administrative core leadership. So we have 2 co-directors, myself and Chuck Nelson at Boston Children's and Harvard. And then we have several associate directors, Pat Levitt from USC, CHLA, and Hugh Garavan from University of Vermont, who is also an MPI on one of the ABCD sites. Danny Fallon, who is an epidemiologist and was at Hopkins, is now the head of the dean of the School of Public Health at Emory, and Cynthia Rogers, a psychiatrist and substance use expert from WashU. And then we have co-investigators that fill very specific roles. Pilar Osorio from University of Wisconsin, who is an attorney and a bioethics expert. And as you can imagine, the ethical concerns with this study and things that we have to attend to are myriad, and it's been incredibly important to have that level of expertise in our administrative core leadership. Terry Jernigan, who is the MPI of the ABCD study, one of the two people who conceived of this and has carried this out so successfully. She is a co-investigator in our administrative core for HBCD, and she is responsible for our what is called results-based accountability. So basically, are you keeping up and doing what you said you were going to do? And then last but not least, Natasha Akshamov, who is a clinical psychologist who is responsible for our infant testing core, training and certification of staff, and for oversight of our site monitors. And then we have a data coordinating center that's led by Chris Smyser at WashU, another ABCD site. And then he is joined by Damian Fair at University of Minnesota, also an ABCD investigator. And then Anders Dale at UC San Diego, who is the PI of the data core for ABCD. So you can see there's a lot of overlap there and a lot of important synergies in terms of being able to not start from scratch in terms of how to handle these data. And then two associate directors, Nathan Fox, who's the expert on EEG from University of Maryland, and Wes Thompson, also the biostatistician for ABCD, now at the Library Institute in Oklahoma, and he's heads the biostatistics core, so to speak, for HBCD. This is a map of where the sites are located. It's actually probably not totally up to date. We've had a couple of sites that dropped out, one early and one added, so the map needs to be updated. The teardrops show where the coordinating centers, the administrative and data core centers are located. And here's a list of the study locations, which you can find on the website. And as I mentioned, these are study locations that were selected based on capacity, expertise, what they could bring to the study, and representing a cross-section of the U.S. population of pregnant persons who deliver in the United States. This is a busy slide, but gives you an idea of the kind of complex organizational structure and oversight of the HBCD study. Let me see if I can make this go. If you look in the center here, we have what's called a Council of Investigators. So this is all of the MPIs for each of the 26 sites are members of this Council of Investigators, and they're responsible for listening to and commenting on recommendations that are made about the study protocol or any other aspects of the study, and recommendations that they agree to go to the steering committee, and the steering committee is the decision-making or governing body for HBCD. And it includes voting members that are drawn on a rotating basis from the Council of Investigators. It includes the MPIs of the administrative core and the data core, and the NIH project director or scientific director, and then we have a couple of non-voting members on this steering committee. And then we have an operations group that really is comprised of the directors of the cores, the associate directors, and the NIH to operationalize and deal with issues that come up over the course of the study. And then external, we have a scientific board that has representatives on it, led by Kathy Spong in Texas, who's an OBGYN, and she leads this external scientific board as a resource to comment on, give advice, and so on about study measures and study progress. We are in the process of naming a national liaison board, which will have members from stakeholders nationally that are relevant to the objectives of this study. So, nominees include, American Academy of Pediatrics and Department of Education and so on, that will be a group of people who can comment on findings of the study or direction of the study in terms of value and meaning for these national stakeholders. And then we have an external observational study monitoring board. So similar to what you would have for a clinical trial where you have a data safety monitoring board, since this is not an interventional study, we have an observational study monitoring board, which is managed by NIH, not by the investigators, as is correct. And they meet now 3 times a year and review protocol deviations, review data on incidental findings that are returned to individuals in the study, and other issues related to participant burden and so on. And then, of course, we have federal collaborators across the institutes. Now another busy slide, but this is just to give you an idea about how we come to make recommendations for the protocol, for how the study is carried out, for changes that need to be made. And this is done using what we call a working group structure. And so you can see on the left here, under the administrative core, we have several committees and working groups that are responsible for various aspects of the studies. And the members of these are drawn from the sites. So as part of their UO1 commitment to the study, they nominate individuals who serve on one or more of these working groups, either as co-chairs or as members to carry out the work of the study. So we have a bioethics and medical oversight group that's one of their activities is to review and approve emergency management plans for each one of the sites. So if there's each site has to have a mechanism and a clinician responsible for dealing with situations where an individual may threaten harm or to themselves or others, or where there's situations that might involve child protective services, and also to deal with other incidental issues that may come up. We have a crisis and communication team to deal with hopefully infrequent, but there will be situations where something comes up that's, oh my gosh, we have to deal with this, and it's going to have, or could potentially have wide-reaching implications. We have a design and epidemiology group who make recommendations about criteria for inclusion-exclusion, for administrative withdrawal and those sorts of things, and about changes to, or recommendations for changes to the study protocol. We have a very active diversity, equity, and inclusion committee. We're in the process of actually expanding that, which crosses over into all aspects of the study, both from the standpoint of diversity, equity, inclusion in staff members and investigators, in participants, and in making sure that we have training opportunities and so on under that umbrella, and that our measures are reviewed. All of them are reviewed with a DEI lens before they are adopted and implemented. We have an ethics, legal, and policy group that has been led by Dr. Osorio, I mentioned earlier, because there are numerous issues that come up with regards to perhaps change in caregiver, issues related to whether or not a person who is in mandated residential treatment, falls under the quote-unquote prisoner category, so they deal with a lot of those issues and make recommendations. And then we have a core recruitment, retention, and community engagement working group that makes recommendations and provides materials for the sites and advice to help support recruitment and retention. And then we have a rural and sovereign communities group, because there are certainly different issues or unique issues that may relate to, especially rural communities where individuals are having to come great distances, relatively speaking, to take part in the study. And then we have a training and professional development committee. And then we have domain-specific work groups for various assessments, and they're listed in the middle here. Behavior and caregiver, child interaction, neurocognition, pregnancy and exposure, social and environmental determinants, biospecimens and omics, novel technologies and wearables, transitions in care, study navigators, I'll say a bit more about in a minute, and physical health. And then under the data core, we have a committee that's responsible for reviewing proposals for ancillary studies. And this could include anything that is an add-on to the study that is not a core protocol item. So not all sites are doing it. And we've had 2 approved so far that involve additional biosample collections, one for placenta and one for additional sample collection mid-pregnancy. And then we've had one approved that's an interview study with the RAs that doesn't involve the study participants. The ancillary studies group is so critical because they have to make the determination and recommendation that if this ancillary study being proposed is adopted, what impact does it have on the core study protocol? So does it threaten ability to retain individuals who are enrolled in the study if we layer on this ancillary study measure or measures, or does it put us in a vulnerable position of not being able to carry out the core study protocol or retain those participants? So those are kind of key issues in addition to the scientific value of the added measure or activity that's being introduced. We are currently in a pause for considering new ancillary studies while we're getting our feet on the ground in terms of recruitment, but we anticipate that there will be numerous ones of these proposed as the study progresses. And they can be unfunded, or they can be a proposal that comes in where the individuals proposing it say, okay, 5 sites are interested in doing this. We want to go in with a grant proposal. The Ancillary Studies Committee can review it. If it's adopted as acceptable, can support that proposal. And then we have a communication, engagement, and dissemination group that very much monitors the content of communications, outward-facing communications to participants and to the public, and make sure that they are clear and at a literacy level that is appropriate. Resource sharing will be part of what we're doing in terms of data releases and other tools that are shared. And then we have a publications committee, primarily for monitoring progress of publications that are considered consortium-wide, where every PI is a co-author. And then we have under the data core EEG work group, an MRI work group, biostatistics, geocoding and linked external data, and I'll say a bit more about that later, management of participant lifestyle, data storage and management, data QC, and analysis infrastructure. Preparation for this study, as you can imagine, was necessary, that we couldn't just jump into it and start recruiting people into a very complex study with a lot of moving parts. So we had an 18-month study planning phase that was intended to address multiple issues in study design, what would be desirable to conduct and would it be feasible to include it, scientific rigor, a lot of work on ethics, participant burden, and feasibility. Now the sites are functioning under a single IRB at UC San Diego, and they all, the condition of the award is they agree to carry out a common core protocol under that single IRB. So that is a huge management challenge, but is the way the study is structured. It's a single study and not 26 separate studies who are contributing data. The additional study enhancements, as I mentioned, ancillary studies that are conducted at a subset of sites. I mentioned the 3 that have been implemented, and others may be considered in the future. And then each of the sites some have more than one community advisory board, which is critical to their connection with the community, making sure that community members are aware of what the study is about, how the study is progressing, and also seeking their advice on at various aspects of the study or hurdles or problems that individual sites may have, but may be common across multiple sites. The study navigators I mentioned earlier, I think this is novel. This is new to this study. It was a suggestion of a group at University of Wisconsin who thought that there would be benefit to having peer support people, particularly for individuals who had substance use difficulties, to be able to be kind of their person on the ground to help them in whatever way was requested or needed, navigate through the study. And having health issues and having social environmental issues, and then trying to be part of a complex study, you can imagine is challenging. So the way that this was set up is that we awarded from the administrative core sub-awards to each site to support at least one designated study navigator. Some of them are peer counselors with lived experience. Some are not, but they all go through a training program to play that role. And they all provide support, facilitate referrals for services. They have more frequent contact if the participant asks for it or is willing to engage with the navigator, and help in many ways to keep the participants engaged, feel valued, and address obstacles. And so far it has been judged to be quite successful for the people who have taken it up. And it's not limited to people who are in our substance use exposed group. Anybody in the study who wants to use their services, it's available. And importantly, we have integrated them with the research team. So they meet annually together with the research team. They attend joint calls, and the research team and the study navigators are intended and encouraged to partner. So this is a kind of dense slide, but just to give you an idea about the sampling strategy in the general population of pregnant persons, we estimated that about 8% would have substance use exposure for our 4 target substances. And so if we just recruited all comers, we might come up with that 8% in the general population, but that's not the target design of the study. So our target is 25% overall, any substance use in pregnancy meeting a certain threshold criteria set for each one of the substances for the 4 substances listed here. So opioids, marijuana, alcohol, and tobacco. And within each one of those substances, the target is 12% of the overall sample, recognizing that there is, and we expected to have co-exposure. So this was based on estimates of pregnancy substance use in national surveys and the polysubstance use correlations. We recognize that it'll require the most enhancement to get that 12% of opioid exposures in the opioid group, because it's about 1% in the general population, whereas we expected it's a little easier and only will require modest enhancement for marijuana and alcohol, and tobacco use is prevalent enough that we're likely going to achieve those goals without a lot of additional focused effort. So as you can see on the target sample on the right, it's 25% substance using, but importantly, to be able to address all of the myriad of factors that may contribute to adverse outcomes in addition to the substance use. We have a target of 25% who are similar but not substance using. So similar on various covariates, but have not used these substances in pregnancy. And then 50% of the sample is intended to be general population, and that will include, of course, people who do have some alcohol exposure, some marijuana exposure, but don't meet the threshold criteria. And then the idea is the design group has developed an adaptive enrollment strategy via real-time monitoring to achieve recruitment goals. So rather than kind of sitting back and seeing what we get, that data is entered into an enrollment dashboard and evaluated periodically. And as we're now about 6 months into it, we will now be starting to develop propensity scores on various characteristics, including race, ethnicity, education, urbanicity, poverty, deprivation index, that might be associated with being having substance use that meets the study criteria, and then making sure that we're propensity matching, so to speak, that 25% by site and overall who are similar but have not had substance use exposure in pregnancy. And so the idea is that this adaptive enrollment will monitor by site and overall in the study characteristics of those who meet the criteria, in other words, monitoring propensity for exposure, and adapt recruitment as needed at those sites to ensure sufficient numbers of propensity-matched individuals are also recruited to achieve that internal validity. So to be part of the study, you have to be 18 years of age or older. You have to be available and willing to be part of the study with your live-born child for 10 years, recognizing that there will be changing caregiver, there will be people that move out of the area, and we will accommodate those circumstances, but at the time of enrollment, screening and enrollment, that's a criteria. They have to agree to the requirements of the core protocol. The only exception is that the biosamples that are collected, they can opt in or opt out of genetic uses of the biosamples for themselves or for their child, although we've had close to 90% who have opted in. Unfortunately, we are conducting the study only in English or Spanish, and I think a little over half of the sites are offering the study in Spanish based on their catchment area, but those are the two languages it was feasible to do. We're targeting second trimester enrollment, so wanting to be past the high-risk period for miscarriage in the first trimester or late first trimester, but being able to enroll people in the second trimester when we have an opportunity to collect biosamples and do maternal interviews about substance use and other factors in pregnancy closer to the time that they happened. Although we are allowing third trimester enrollment, and we are allowing up to 10% of the sample to be recruited postnatally for the reason that there are people who may not have received prenatal care or for a variety of reasons are not identified until after birth. This is a schema showing the first study visits as they've been laid out, and I'll say that the first 3 visits are pretty much being implemented and going ahead as planned. Visits 4 and 6 are being piloted, and some modifications are going to be made to those based on the visit length. But in general, these are the in-person visits over the first 5 years. We're discussing now the possibility of being able to take that last lengthy time window of 15 to 48 months and divide it into 2 time windows. But as you can see, we're collecting questionnaire data at all in-person visits, biospecimens from the mom in the prenatal visit, visit 1, biospecimens from the child in all subsequent visits. We start at visit 2 postnatally with the MRI and biosensors, and then visit 3 at 3 to 9 months is the first EEG, biosensors, and MRI again, and then continuing with that in visits 4 and 6, and then there are remote visits with questionnaires in between. In addition to that, we have consent to release medical records from the OB, the birth hospital, and the pediatrician, and an annual request for release of pediatric records. This is part of the core protocol, but we're pilot testing it now because it's our experience is that there are people who will decline to participate in a study if medical records are a condition of enrollment. So we've in this pilot, we just started a couple of weeks ago at screening. If an eligible person declines, where they're being asked what the reasons are, and if one of them is release of medical records, we'll be able to capture what impact on the study recruitment having this as a requirement will be. And then we're also pilot testing being able to capture this from health systems using EHR with an electronic data pull that's set up to occur automatically, and then the much more laborious manual collection of medical records from pediatricians in the community, for example. I mentioned earlier that there's a working group on geocoding, and they're setting up geocoding of residential addresses. So as the participant and family move, as they will, over the course of pregnancy and over the course of the child's 10 years, and addresses where the child spends significant amounts of time, such as in a daycare setting or another family member's address. And the purpose of that, of course, is to link to external data sources to be able to look at air pollution, water quality, built environment, other kinds of environmental factors that may impact child development. So this is extremely tiny, but I'll just spend the next couple of minutes, and this is available on the website. So you can go in and look at what the, I even have to put my glasses on to read this. You can go in and look on the website to see what the measures are, not updated in 10 minutes after any change is made, but pretty much current. So this just gives you an idea from Visit 1, that's prenatal, that the APA, American Psychiatric Association, Level 1, questionnaire is administered on current mental health symptoms, including depression, anxiety, sleep problems, memory, psychosis, and personality functioning. And then depending on those responses, the more detailed current mental health symptoms, including anxiety, depression, anger, sleep disturbances, mania, and so on. And then DSM-5 severity scales for acute stress or PTSD. The Edinburgh postnatal depression scale done in pregnancy for symptoms of prenatal depression in this case. Family history assessment module, so looking at family alcohol and substance use and psychiatric history, and then health history, parental and current pregnancy health history, including medications and other substance exposures. In terms of assessments of substance use, we are using the ASSIST for lifetime and prenatal substance use, and then following that with a very detailed timeline follow-back interview, which provides quantitative estimates of prenatal alcohol and substance use over relevant time windows in pregnancy at the time of enrollment and just prior to the time of conception. We're collecting maternal blood, whole serum, and plasma at that prenatal visit, and then maternal nails. Toenails are the preferable source of nails, and these are being assayed by U.S. Drug Testing Laboratory for substances and can be used for environmental exposures. Maternal saliva and maternal urine, which can also be used for substance exposures and environmental exposures. The baby's first year's services support questionnaire for benefit programs and services used during the last 12 months, an economic stress assessment during the past 12 months, extensive demographic questionnaire, a questionnaire about intimate partner violence, PROMIS, social support and perceived stress, PACEs, protective and compensatory experiences, the FENIX discriminatory treatment during the past 12 months, and the FENIX neighborhood safety questionnaire, and then work-related environmental exposures, a questionnaire about environmental exposures related to employment, including temperature, physical activity, noise levels, and safety and protective equipment. And then visit 2, the window is 0 to 1 month after the due date, so that they're gestational age-wise, in a similar window. If the child delivers post-dates, then it's 0 to 1 month after the birth date. And at that point, there's a 2-item food insecurity screen, FENEX breastfeeding questionnaire. Mobile technology is implemented at this time because there's an infant. So there's an activity survey that the parent completes, and then there are 2 sensors, a Gabi heart rate sensor that's worn for 72 hours by the child, and movement sensors that go on the ankles, and they measure sleep and wake cycles and with an accelerometer and gyroscope for movement, and those are worn for 72 hours as well. And then brain imaging, there's diffusion MRI, functional MRI, resting state MR spectroscopy, quantitative MRI, and a structural MRI T1, T2. And then additional questions, so a repeat of the APA and the level 2 APA questionnaire, repeat of the post-traumatic stress scale, a repeat of the Edinburgh postnatal depression scale, and an update of the health history. And then the assist again, and a timeline follow-back that covers the last few weeks of pregnancy, so to capture that window after enrollment but before delivery. And then child specimens, saliva, stool, urine, and parental nails. And the nails are the second window of being able to look back at substance use exposure in the last part of pregnancy. And then culture and environment measures on social support and perceived stress, measures of weight, length, and head circumference of the child, and the health history for the child, any medications that they may have used. And then the last one, visit 3, I'll discuss at 3 to 9 months. Again, the APA level 1 and level 2, again for the parent, the severity scales for PTSD, Edinburgh depression scale again, alcohol, smoking, and substance use, biospecimens again from the child, and then parent-reported outcomes of perceived stress, another anthropomorphic measurements of the child, the food insecurity screen again, and a breastfeeding questionnaire. And then the mobile technology repeated again at that visit 3, so the Gabi heart rate sensor and the child movement sensors, brain imaging, the same set of scans done again, and then EEG is introduced at visit 3 in 3 to 9 months. So FACES task, mismatch negativity, auditory, oddball task, video resting state, and virtual evoked potential task. And then neurocognition, at this point, we're introducing, and I think working in collaboration with the NIH Baby Toolbox, which is just being launched. So using some components of the NIH Toolbox, Baby Toolbox at that point, and the sensory processing measure 2, or SPM2. And then finally, early regulation and context assessment, or ERICA, is being administered at this visit for affect and self-regulation behavior in children and families, promise caregiver-child interactions, family culture matters measure, infant behavior questionnaire, IBQ, and a multidimensional assessment of profile temper loss scale, and all of those are done at that visit 3 to 9 months. And I should say the way that the participants are enrolled in the study is at the time of visit 2, when the baby's born, they're randomized to a jittered assessment schedule across the rest of the subsequent visits, so that not all babies come in at 3 months, or not all babies come in at 9 months. They come in at various windows across that range, so we're representing the entire trajectory. So I'll say a word about the website. This is it's really pretty current. So the study measures are up there, the brochures that are provided to the participants. There's a scientists section. Our publications will go there. So it's a good resource to be able to find up-to-date information. There's newsletters and announcements about meetings and other events. And in terms of study progress, I'll say that I mentioned that we completed pilot testing, the protocol for visits 1 through 3, and we have launched the main study last year. We're now testing, pilot testing visits 4 through 6, and we plan to have that completed by June of 2024 when the first families will come in for their visit 4. I'm very proud to say that we've recruited over 1,000 families, so that's a huge hurdle, but it's wonderful to say that we've been able to engage across the 26 sites, that many families. That being said, that's 15% of the total sample, so we got a long way to go. And we're learning a lot in these early months about where the stressors are, what's more difficult for the staff, what's more difficult for the participants. For everyone in the audience, I think this is amazing that this is going to happen so soon, that we anticipate the first data lock in July, so just a couple months down the road, and that will include completed visits 1 and 2, so it'll have the first MRI in there, and we anticipate the first data release, and as you know from ABCD, this is an open science data model, so what happens is the data on an annual basis, a curated, de-identified data set will be released. Individuals, anyone who wants to apply, applies with a data use agreement to be able to use a specified set of data for a particular purpose, and it could be to propose a grant funding initiative, or it could be to do secondary data analysis for a publication, it could be for a dissertation, could be for any reason. And this is available to anyone who can meet the criteria for the application at no cost. And this is true for the investigators in the study. So it's a really different way of approaching things. So here you have hundreds of investigators in the study who are working their tails off to collect these data, and they have to get at the front of the queue when the data are released and apply just like everybody else for use of those data. So the plan, the data coordinating center, Damien Ferrer, tells us that he thinks the release will be ready by the end of this year. As soon as it's anticipated being released, I'm sure there will be plenty of announcements about this coming up, what you need to do to apply and what the content would be. And it's not only will be a curated data set, but we'll have data release notes that will help individuals understand what's in the data set and how they can use it. So ending, I'll say the study is designed to answer questions about child development with a focus on brain and behavior, including mental health over critical early years of life. But most importantly, I think this is going to offer scientists across the globe unique opportunities to better understand the interplay between complex factors that influence developmental trajectories over time. So thank you so much.
A couple of questions. Questions for Dr. Chambers?
This is incredible in terms of the extensive number of variables that you have and also your timeline. But I did actually note one missing thing. So I know you're very well known for your breast milk Biorepository, and I didn't see that there.
You are just so wonderful to say that. So, yeah, you know, that the question, and I think for those that are listening remotely, the question was that a notice of a missing piece, which is breast milk itself as a biosample. The biospecimens working group considered it carefully in the prioritization. They decided that this was not the top priority to collect. I think it should have been, but that's, I'm one voice. But honestly, what I think will happen, I mean, we're already, 15% into this, and if we're going to collect it, we need to make a decision about it pretty soon. As soon as we open up for more ancillary studies, there is a lot of interest at multiple sites on being able to add that as not too much additional participant burden for a lot of gain. The opportunity to do that would be as an ancillary study, and maybe 20 out of 26 sites would do it, but it would be an incredible addition. I agree. Anything else?
All right, let's then hear a shout out for Tina.
Okay, thank you.
And I'd like to invite the co-MC, the director of the Imaging Core, Mike Yassa, to introduce our next speaker. And we're shifting gears, so hang on to your horses.
Okay, good morning, everyone. I'm realizing now that whoever is standing here is getting this bright light shined directly into their eyes. So good luck with that. So our next speaker, we have two talks today from local UCI colleagues. Our next speaker is Dr. Jared Rasmussen, who's one of our co-investigators in the Conte Center, and he's an assistant professor in the Department of Pediatrics. And he's going to be speaking to us today about leveraging large-scale neuroimaging data sets for deeper insights into investigator-initiated studies. So, Jared.
Hi, good morning. So I'd like to begin by thanking the organizers for the chance to speak and you, the audience, for yielding your time to hear this talk about using large samples to leverage deeper insights into smaller samples. Figure out how to click through these. Okay. So this talk focuses on neuroimaging, of which I'd argue that there have been some big wins for clinical applications. These cases include the classification of stroke that fundamentally changes the course of treatment. Tumor progression can be tracked using MRI to gain insights into treatment response. And MRI in Alzheimer's and dementia can be used to monitor disease progression. So in addition, neuroimaging is a useful tool in surgical planning through the use of 3D mapping white matter pathways and functional activation regions in the context of planned resections. But there are also unrealized promises, like a firm understanding of more complex disorders relating to mental and physical health. And further, these methods aim to provide personalized medicine for the primary prevention of disease, and we simply aren't there yet. So today, I'd like to talk and touch on two things that I think may be contributing to holding us back from realizing these promises. The first one I'll speak to relates to research using small samples. While they inarguably provide a framework for rapid innovation and testing of specific hypotheses, they are also prone to a lack of replication under different experimental conditions or when their findings and frameworks are applied to novel populations. So this problem has received a lot of attention recently as we begin to understand that simple univariate brain-behavior relationships, at least the way traditionally modeled, are likely weaker than originally expected. Examples between neuroimaging measures and observed behavior are typically on the order of less than 10% variance explained for very large samples. Further, you can see on the left that at small effect sizes, there's a lot of heterogeneity in findings, as you can see in the spread of correlation coefficients. And when this is done when randomly subsampling a large data set, and this leads to spurious results and what would manifest in the literature as conflicting findings between studies. This concept also extends beyond univariate analyses to multivariate analyses, as shown on the right here, where we tend to see inflated effect sizes. So large samples are really touted as a solution to this, but large samples historically have been constrained to simple measures, right? Typically something like a self-report survey. Examples of this are the census, collecting demographic data in over 3 million people in a census year. A step down the ladder might include the National Health and Nutrition Examination Survey that collects a diverse set of simple health data on thousands of individuals in a given year. So these studies can be surprisingly rich in data, yet smaller investigator initiation studies tend to focus more on mechanisms and/or disease states that might include a greater depth of study. So further down this cartoon, you'll find animal experiments that can be exceptionally controlled and provide rich data at the cellular and molecular level. And we often sort of use this analogy of a mile wide and an inch deep versus an inch wide or a mile deep. However, this distinction has recently been blurred with the advent of mega-analysis consortiums and institute-initiated studies like the ABCD or the HBCD. And these are conducting large-scale data collection, including neuroimaging. So these studies represent an immense resource on their own for discovery science that is reflected in the thousands of research products that they've provided to date. However, I'll argue today that these studies are also well-suited as validation cohorts for the partial replication and/or generalization of small study findings, thereby providing an invaluable resource for extending the impact of small samples. So one such example focuses on the paraventricular thalamus, or the PVT for short, which is a key node in emotional memory brain circuitry with implications in motivated behaviors and mental health outcomes. This is a small structure located along the midline of the thalamus, yet with a highly specialized and distinct neuronal population. This region has become a key focus of the UCI Conte Center, which is a primary reason I choose to highlight it here today. Early tracer studies established the notion that projections from the PVT are densely connected to limbic regions They're also relevant for saliency of emotion and memory like amygdala and hippocampus. So the UCI Conte Center has really been a leader in establishing the importance of the PBT in human behavior, establishing its sensitivity to adverse early life exposures, its relevance to psychopathological outcomes, and furthermore framing these ideas in a sex-specific manner, helping address an important need in appreciating sex differences. The UCI Conte Center and its imaging core have taken this work an extra step further by identifying what the functional connectivity of the PBT looks like in human adults based on high-resolution Human Connectome Project 7T data, partially replicating its patterning in standard 3T resolution, and even replicating in developmental populations. So you can imagine our delight when recent preliminary analysis demonstrated sex-specific effects of adverse childhood events on PBT to hippocampus connectivity during adolescent development. While this hypothesis-based work is convergent with animal data, increasing our confidence in its observation, we are still sort of stuck in this modern landscape of spurious findings in small samples. I use small samples loosely here that this is some 200 observations in about 100 individuals, but still, partial replication in a large external sample would certainly provide additional insight. So this is what we pursued in a preliminary analysis of functional connectivity data, leveraging the publicly available ABCD study data. This particular analysis was constrained to 2 sites at first look in about 600 individuals. As you can see, the connectivity maps held in the larger sample is shown at the top, and consistent with our small sample data, the PBT hippocampus connectivity association with adverse childhood experiences was sex-specific with an effect only in girls. So building on this, we have some increased confidence in the sample and connectivity measures. We felt more comfortable in the Conte Center data that considers more innovative measures of early life adversity like unpredictability. Specifically, you can see here that this relationship then generalizes to another critical dimension of adversity. And collectively, you can see how this design incorporates multiple scales of findings to tell a more complete study than I think either the large or small sample could do in isolation. So to summarize this first point, my assertion is that large samples are ideal for replication and generalization as they are sensitive to small effects, which may be especially relevant when considering across diverse populations. So this then leads to the second point I'd like to make. Oops, I'd like to go back. Well, I'll skip that line, but I'm really just talking about the complexity of data and the complexity of brain data. So on the left, I'm showing a typical example of univariate localism where activation of one brain region A leads to a specific behavior green, whereas a region B leads to behavior blue. It's not to say that this model is necessarily wrong. In fact, we know it isn't, and there are well-known instances of it, but there are also examples of degeneracy in the brain where different activations of regions can lead to the same green behavior, suggesting that things may be more complex than a typical model might consider. Another example here is the concept that A and B are both required for behavior red, an instance of network-like behavior. In circuits, one might consider these if-ors, and if-and models. So, and I believe the best way to handle this complexity is either through good experimental design or proper complex modeling. However, in small samples, there's a high likelihood of overfitting data leading to high variance models, as shown in this diagram on the left, where you can see the trade-off between bias and variance based on model complexity. So simple models tend to underfit the data leading to bias, whereas complex models may overfit the data leading to generalization errors and high variance. But as we all know, even simple models can overfit the data when there simply isn't enough of it. So these axes are, again, just showing here the main point I'm trying to make is that complex models require big data. So to finish, I'll present a brief synopsis of preliminary analyses we're currently investigating with collaborators that expands this idea of polyneural risk scores or the accumulation of small effect sizes to predict behaviors, also referred to as brain-wide association scores. It begins with the training, testing, and validating of a multivariate effect in a large sample to provide a set of beta weights that can then be used to derive a risk score. So you can think of this as just a large linear model, which it essentially is, just regularized to achieve robust estimates of these small effect sizes. So this framework can then essentially take any behavior in the large data set as an outcome and any imaging data as input. And because you're doing a training and testing split, you can really use any model or complex model you want as long as you're able to validate it. So again, this is in the ABC data set. In this specific example, we tried learning on brain functional connectivity to predict internalizing behaviors. And then we asked a simple question, do the beta weights or brain-wide association scores derived in adolescence generalize across developments into infants? We have infant brain measures harmonized to be ABCD-like so that we can simply apply the beta weights much like a polygenic risk score. The answer isn't so clear. The effect size is roughly what one might expect, but I also wouldn't say that the observed association is particularly convincing with respect to generalization to infants. But what does become interesting using this framework is because this particular sample is deeply phenotyped with respect to the maternal environment during gestation and behaviors in early life, we are well positioned to ask questions about causes and consequences of these brain-wide association scores in the infant brain. So for example, does maternal inflammation impact these brain scores, or do these brain scores predict behavioral outcomes like positive or negative effect? And we're actually eagerly awaiting HBCD data so that we can more closely align these two samples. But within adolescents, this is a second example from Dr. Christine Chambers' lab, who we'll hear from later today. We conducted a similar study and leveraged the ABCD sample to derive these brain-wide association scores with cognition, to then apply to her Kids to Health sample, which has detailed phenotyping on childhood trauma exposures, and have been deeply phenotyped with respect to mental and physical health outcomes. So while this work is ongoing, we'll be positioned to answer key questions about determinants and the ability to generalize from the ABCD sample to an international smaller sample cohort. So I'll then conclude with the assertion that large samples provide a more well-posed framework for discovering complex brain-based models of behaviors that then can be applied to smaller samples for deeper research insights. So I've glossed over these examples quickly because of the short time of this presentation, but you can imagine that they take an immense amount of resources to create, and I'd like to really take the time to acknowledge the following contributors from the Conte Center here at UCI, and the folks across the country and globe at the Charité, Oregon Health Sciences, and the University of Minnesota. And finally, I'm going to leave this last slide up as I exit, as I think these are great examples of these concepts, elegantly put into practice, and are definitely worth a read. And if you're interested in these concepts, I think these papers are a good place to start in terms of how to actually conduct these studies. Yeah. Okay, that's it.
Yeah, so we have time for a couple of questions if folks would just like to come up to the microphone, or Dr. Barron.
So it's more of a philosophical question, if you will. It's a very short one. We are aiming to look at the correlations across the population, but we just learned from Dr. Chambers that in order to get a handle on things that are pretty rare, such as opioid abuse, which is 1%, we are enriching in it in our data set. So we have a different population distribution than quote-unquote the real world. How do you handle it?
Yeah.
Ask you to repeat the question very briefly, just because Vitaly wasn't at the microphone when we have a Zoom.
Okay.
Do you think you could do that?
Yeah. So the question is that, and correct me if I don't get this quite right. So we have these large samples that we're gathering and that we're enriching, for example, in the HBCD data set for exposure. And so because that's not the normal population, how do we really account for that? I don't know if there's an obvious answer for that. I think that's going to be in the modeling. An easy way to do it is ignore the substance users and just look at the normals, and it'll still be a very large sample, much larger than anything we have to date. But then you're sort of ignoring generalizability across lower SES, and I think that's sort of the beauty of the design, is that you're matching propensity, so you can include those individuals as well. But I don't know if there's an obvious and easy question yet answered for that yet.
Okay, I think we'll break here. Thank you, Jared. And we have a few-minute break before our next speaker, so I will invite you all to flex your legs, take a little break, grab some water or coffee, and come back in at 11 o'clock is when we'll start.